So here we're going to do another proof using the method of contradiction. We're going to show that for any integer n greater than 3, 2n minus 1 over n minus 2 is smaller than 2n plus 1 over n minus 3. So please put your video on pause and write that out in symbols for me. Here it is in symbols. It's really a conditional statement. It says for every integer n, if n is bigger than 3, then we have this inequality. Okay, so if someone suggests to you that maybe you should try to do it using the method of contradiction, what would you have to do? What would be the basic idea? At least from a mechanical point of view, you should certainly know how to get started. You should say, well, suppose it's not the case that this happens, and then you'd write down a useful denial of that. So what is a useful denial of a statement of this form? Well, we have a statement of the form for all n in z, and then it's some kind of a p implies q format. So in order to negate that, or in order to take a useful denial, we would put there exists an integer n. And now I hope you remember how to take the negation of a p implies q. It's not conditional anymore. It's p and not q. P and not q. So that means for the statement that we've got in front of us, it's there exists an integer n such that n is bigger than 3, and the negation of that inequality, which is to say 2n minus 1 over n minus 2 is bigger than or equal to 2n plus 1 over n minus 3. Okay, so if we're going to do proof by contradiction, we would start by saying, well, suppose that there exists an integer n such that n is bigger than or equal to 3, and this thing happens. And then you would try to do some kind of a calculation to get a contradiction to that. So let's do a calculation. Let's work on this inequality here. So let's write it down again. We've got 2n minus 1 over n minus 2 bigger than or equal to 2n plus 1 over n minus 3. So we can work with inequalities the way we work with equations. I'd like to clear out the fractions, and so what I'm going to do is I'm going to multiply both sides by n minus 2 times n minus 3, and that will have the effect of, making the 2n minus 2 disappear on the left, and the n minus 3 on the right will appear here, and the inequality will be preserved. Why will it be preserved? Well, it's preserved provided the thing we're multiplying by is bigger than 0, and we know that to be the case because n is at least 3, and therefore both n minus 2 and n minus 3 are positive. Okay, so we get this, and now multiply out. You get 2n squared minus 1 minus 6, so that's minus 7n plus 3, bigger than or equal to 2n squared minus 4 plus 1 is minus 3n minus 2. And now we can simplify. The 2n squareds go away. And if we bring the 7n to the right and the minus 2 to the left, we get what? We get 4n less than or equal to 3 and 2 is 5. And what can you get from that? That tells you that n is less than or equal to 4/5. Right? N is less than or equal to, or rather 5/4. And that's in a contradiction, because we started off by assuming, remember, that n is at least 3. Right? So we have a contradiction when we say that if you have that inequality, n has to be less than or equal to 5/4. Okay, so that's the basis of the proof. See if you can make use of that to write up a formal proof. And when you come back, you can compare your answer to mine. Okay, so here's my proof. I begin by telling the reader that I'm going to argue by contradiction. So I say, suppose it's not the case that, and then basically I write this down. It's not the case that for any integer n greater than 3, we have this inequality. And now basically I'm writing the useful denial that I had put over here on my scratch page. Then there exists an integer n such that n is bigger than 3, and this happens. And now I'm basically summarizing the calculation that I did in here. So I say, since n is bigger than 3, this quantity is positive, so multiplying the inequality in 1. So that's why I displayed that first inequality, because I wanted to refer to it. Multiplying that by this gives this, right? So that was the calculation that we did before. You don't have to show all the details of the calculation. I think the reader can fill that in for him or herself. So I also numbered that one and put it in a display because now I'm going to refer to it. Simplifying the inequality in 2 gives that n is less than or equal to 5/4. But since we've also assumed that n is at least 3, remember that was up here, that was our assumption, we have a contradiction. Thus the original proposition is true.